Oh, hello there. I just finished drinking my delicious Starbucks coffee, and I thought of a question that I know all of you coffee-drinking, physics-loving fiends have pondered as well. Today we're going to answer the question, if I were to drop my Starbucks coffee cup from an elevated surface, could I calculate its acceleration? I bet 1,000,000 Starbucks you can. Now let's do it. Okay, I'm going to time this as I drop my cup from this elevated surface right here, which I measured in meters, and I forgot what that number is, but I will tell you later when we do the calculation segment. Okay, here's trial 1. Wow, a whopping 5.53 seconds. Let's do it again. Wow, I happened to get the same thing. Last time, here we go. 0.51. Okay, now we're going to move on to the calculations in my next segment. Thank you. Who's ready for some calculations?
We are!
Great, let's get started. Okay, as you can see here, I have all the recorded times from the drop of the Starbucks cup, and the average time was 0.52 seconds, listed right here. Our purpose is to find the rate of acceleration of the empty Starbucks cup, and our answer will go here and we're done. Okay, the first thing we're going to do is construct a position versus time graph. I'm going to draw it right here. X versus t right over here. Okay, so the height of the drop was 0.9144 meters. The average time was 0.52. Our line will end up looking like this because it's constantly increasing in position, acceleration. That's what it looks like. Okay. Now we are going to find the average velocity, which is the slope of this line right here. And the average velocity is equal to the change in position over the change in time, which in this case is 0.9144 meters divided by 0.52 seconds. Now we're just going to punch that into the calculator. 0.9144 divided by 0.52. Our answer is 1.76 meters per second. Okay, now we have what we need to calculate Now we have what we need to calculate acceleration. Acceleration is equal to the change in velocity over the change in time. Now we're going to construct the velocity versus time graph to provide a nice visual thing. Okay. Velocity is here, and as we calculated, it's 1.76 meters per second, and that's the average velocity, so it goes right here in the middle. 1.76. And then our time is 0.52, goes right here. Now the halfway point in time was 0.26 seconds. And our line will be going like this at a constant increase. Not very good line. We'll redo that. Okay. There we go. And we're going to find here the average velocity over average time. So we have acceleration is equal to 1.76 divided by 0.26, which is the slope of this line right here. Change of velocity over change of time. And our answer is, let's punch that one into the calculator. About 6.76. And what helps is to add your units right here. We had 1.76 meters per second over second, so we know that our unit should be meters per second squared. And now we can plug this into our purpose, and we found that the acceleration of the empty Starbucks cup was 6.76 meters per second squared. Thank you for watching.